So, here's what's up. I got to run through a few things with you guys. On Schoology, in the Help Me folder, the Chapter 3 Solutions video is up. So exactly what we had done yesterday, if you come to your Schoology, and you go, yeah, Miss Jackson, she has a really weird picture. If you go to the Materials page, and you go to the Help Me folder, in Unit A, because that makes sense, you need help in Unit A because it's Chapter 1, 2, or 3. Then Chapter 3, if you need any continued help with that Chapter 3 mastery, here's the entire thing, question by question. Then reminder, if you need a progression to mastery, Aiden is showing you where the progression to masteries are if you need one. And make sure you turn it all in together. Your due dates have been adjusted because we did not move as quickly as possible. They are now correct. 7.3, 7.4 is due at the end of the day tomorrow. And then 7.5 is due at the end of the day Friday. Because we are not going to get done with Chapter 7 until Friday. Which means, and I apologize, but your mastery is going to be on Monday. I have to be out at the WEC. I know Monday masteries are lame, but I'm telling you now so you have plenty of time to prep, get your work done, and be ready for a mastery assessment for Chapter 7 on Monday. Ellie.
Can I try 7.5?
Yeah, I mean, they're open. You can try it whenever you want. Once they go up and they're live, you can give it a shot. 7.5 is just problem solving, so it's nothing new. It just wraps it all together.
Okay, I have one more question.
Yeah.
So on the video on Schoology, is that for like the corrections? Or is that
That's exactly what we did in class yesterday. So the progressing to mastery, you got to do on your own. The video is just corrections. Progressing to mastery is all you. Or if you need help, come see me. So we have 2 problems left to do in 7.3. We had just started discussing this problem at the end yesterday. A flower bed has a frame that's rectangular. So let's go ahead and draw a rectangle. Then what we know about it is that it's 9 feet longer than it's wide. And if we keep reading down through, they tell us that the width is going to be W. So if my length is 9 feet longer, then how I've drawn this is kind of close to what it should be, because if I make these my widths, then what expression could I use for my length? Katie?
9 plus W?
Yeah, 9 plus W, or, because we like to put the variable first, we could do W plus 9. Either way is correct. So if you do 9 plus W, that's fine. I just like the variable first. So now, what it actually asks us for, though, is to solve the perimeter. Now, what do we know about the perimeter of a rectangle, no matter what the length and width and stuff are? How would we find the perimeter always? Josh, your hand was up first.
You multiply
Each
each side by 2.
side by 2? So I like double this side, double that side, double...
No, you go across and you add both of those together and then you add the other side.
So I think what you're trying to communicate is it's 2 times the width and 2 times the length, is what you meant by double each side. So we don't double every side. We're doubling the width and we're doubling the length because they're the same. I have 2 identical widths and 2 identical lengths. So if I plug in the parts of my current rectangle into this formula, we're going to get that perimeter equals 2 times, well, what's our width here?
9.
W. Our width, W. So 2 times the width is just 2 times W. It literally doesn't change.
Isn't it if it's just the same variable, wouldn't that just be 2 times 1?
Well, 2 times 1 W, which will still give you... So this is going to become 2W. But the question is, when I go to do 2 times the length, what's the length of this rectangle? Brady?
9 plus W plus 9.
Yeah, 9 plus W or W plus 9. So when I plug that in, what now needs to happen, because I have a number right up against a parentheses? Derek, what do you think, man?
Think what?
Are you spacing out on me? Yeah, kinda. Can you please make sure you're with me? Because I could tell you weren't engaged with what I was doing. So make sure that I have your attention. Leah, what do you think? When I have a number right up against the parentheses, we got to multiply. And because I have different values in here, how do we do this multiplication? What's that special word? Starts with a D. You can get help if you need. So what do I do? Tell me what I do then, and maybe you can figure out what that word is. I think you will as soon as we say it. You're going to have that. Oh, yeah. Acacia? We distribute. So draw these arrows. 2 multiplies by the W, and 2 multiplies by the 9. So we get 2W, and 2 times 9 exactly gives me 18. Then we combine any like terms to clean this up. Do I have any like terms up here that can be combined? Piper? Yeah. If I have 2W and another 2W, what do I really have? 4W plus 18. This would be our perimeter. On what? I know. That's intentional. And that's because I make the homework. It's no longer Pearson homework. So now take a moment with the people close by you and try to figure out what these sides would be based on what the problem tells you. So take a moment on your own. Try not to look up here. Not here today? Where's Sebastian? He's back there. Oh, you're hiding behind Caleb. So you were head down working. Sebastian, what is the really critical thing to see in this problem?
Oh, the critical thing is like, the critical thing I just need to know is like, the width.
The width, right? What do we know about the width? I'm talking with Sebastian.
Sorry. Okay, the width, I would say it's 1/2 of its length.
Yeah, it's 1/2 of the length. Now the question is, do I know what the length is?
Nope.
Yeah, so I kind of, right? I don't know a number that it is, but I do know that it's L. So how can we represent, Aiden, how can we represent the width? What would we actually put over here? Because we can't just put W. If the width is 1/2 of its length, and we know the length is L, how would we represent half of that? 1/2 what? 1/2 L. So my width is just 1/2 L, or you could put L divided by 2. Because if I divide L by 2, that's half L. So I could have half L here, or L divided by 2. Either way, doesn't matter. Now set up your perimeter formula. So perimeter, again, is 2 of the width plus 2 of the length. Now when we start to plug values in, what did we say our width was? Half L, right? What's our length?
L.
Just L. So we're in 7-3. Notes not from yesterday, but from the last time that we were together. before yesterday. What happens when I double a half? It makes a whole. So I have a whole L plus 2 more L's. What do I get? We get 3L. So the perimeter of that rectangle is 3 times whatever the length is. Any questions on any of that? Diving into 7.4, we're getting into, please pass these back, guys, just to save time. Oh, you don't?
I'm telling you to reach it. You're just putting it over your shoulder. Exactly. Reach forward.
You got a question? What is it?
So,
You got a question? Guys, stop talking. I'm trying to hear the question.
I knew how to do that, but I was having like a brain fart moment because there were no
Hard to
numbers.
explain.
So I thought I didn't know what to do
I gotta
because there were no
find
numbers.
where the other one's going. This morning class must have put some back in the wrong place. So I agree. So Zion's saying, so this was difficult because there were no numbers. So what you got to look at is what can I relate? So when it tells me the width is half the length, well, if we knew that the length was like 20, that'd be easy. Half, that's 10. But we don't know what it is. So you have to then look at what do I have that represents the length. You with me, Zion?
Yeah.
And then just take whatever that representative value is, which is a variable, cut that in half, which we know we can represent by multiplication of a half or division by 2. So that's just kind of how we have to, it is difficult. It's more difficult because we don't have numbers, but that's how we have to deal with that problem. Looking at 7.4, once this captures, we are now getting into subtracting algebraic equations, or sorry, expressions, which is more difficult. I will tell you guys this right now. I know that this is difficult. I will not tell you that it's easy. If a friend tells you that it's easy, they have a different brain than you, and they might be lying. This is difficult. There are 2 methods that we use to do this, and the second one seems kind of dumb at first, but it will make sense. So just trust me, please. Let's get through a few examples, and it will totally make sense. So for right now, all I need is your eyeballs. I just need you focused on what we're doing up here. The first method is essentially distributing an opposite. So what we do here is we see we have x plus 4 minus 2 minus 7x. Now minus, or subtraction, is the opposite of addition. So when I see this, what I know I need to do, and now please go ahead and grab your pencil, I'm subtracting the 2, and I'm subtracting the negative 7x. So all they really do is the x plus 4, nothing changes. So then, instead of a positive 2, it's now minus 2. And instead of a minus 7x, we subtract negative 7x. What happens when I subtract a negative 7x? I'm really gonna.
Doesn't it go up instead of down?
Yeah. So guys, right above here, subtract negative 7x, we really add 7x. Because when we subtract a negative, we really add. The opposite of subtraction is addition. Yeah. Yeah. I have no idea how the frame is going to look now, but is that better? You are welcome.
Well, you could turn the angle like slightly that way.
Yeah, but now I can't see. So actually, if we want to see it, I have it set that it doesn't cover while I'm filming. So, now that we got this, any questions on how we're distributing the subtraction? Like, we're going to have to subtract each of those values. Then, we process down through. The only thing that happens here from this step to this step is they change their minus a negative into plus a positive. That's the only thing that happens. Then, they rearrange right here in this step. What's it called when we rearrange values? We move them. What's it mean to move? Yeah, we commute means to move, so this is the commutative property. And then we just combine. We just simplify. So we combine my x plus 7x into 8x, and my 4 minus 2 gets me 2. Any questions on this first process? The next process is going to seem complicated, but I want you to just know, and actually I don't even want to explain the next process yet. Let's skip it for the moment. We'll come back to that. These first two problems, let's do those using the original process method. So we are going to distribute that minus or that negative. So draw the arrows from the minus. It has to apply to everything in the parentheses. Well, it'll make them the opposite of what they start as. So in this problem, yes. But be careful thinking that always, because it doesn't always make them negative. It makes them the opposite.
There's a subtraction symbol against parentheses.
Yeah, it does the opposite to everything inside.
Okay,
So I'm going to color code this. Nothing happened to the 16M. It just drops down. That's why I'm going to use blue. But now I'm going to use red for what my arrows did. My arrows made my 3 a minus 3 and made my 8M a minus 8M. I could also write this as plus negative 3 plus negative 8M, but that's kind of dumb. That's like a waste of effort and a waste of time. So if you can identify the opposite of positive 3 is a negative or minus 3, the opposite of 8M is a minus 8M, then you're good to go. Now we want to group things with each other so we can combine like terms. Allie? The 16M and the 8M, so I'm going to move things. I'm going to move my 8M to right next to my 16M. Any questions on how I did that? I'm allowed, with addition and subtraction, to move anything I want as long as the sign in front of it goes with it. So technically what happened here was this minus 8M moved right here. This minus 3 moved right there. The signs went with them. People always, especially with this problem, like to think, oh, just the values move. The value and the sign goes with it. So now I can combine 16M minus 8M. If I had 16 monkeys and I gave away 8 monkeys, how many would I have left? 8 monkeys, right?
Did you do that because there was an M at the very
Yeah. Then the minus 3 doesn't do anything because it can't. And we're done. Any questions? You made that symbol for the first time? It's tough.
So wait, the answer's 5?
No, because this is not an M value. This is variable. This is constant. We're done. We're done. We're done right here. We cannot combine these. That's the issue, Josh. These are not like terms. Can't be combined. They don't like each other. They really don't want to hang out with each other at all. They will not let us combine them.
They need to be nice. But 8 has M. So I'd rather, if I were 8, I'd hang out with
So, take a moment. Try the first step on your own, where you distribute on the second, where you distribute that negative to both terms. And really, you're distributing an opposite, remember, because bells and whistles, this problem is slightly different. What do you mean both ways? Because we go left to right. So Ella's asking a really good question here. She said, but what about the first parentheses? This minus is up against the first parentheses also. But we go left to right. So that's why this can only go this direction. Now, what would be different is if there was a number on the right side of this parentheses, that would still have to multiply. But this is not multiplying because we only multiply as we're going this way. So this, my 1/3 minus 9, nothing changed, I drop it down. Then, Acacia, what happens in my second parentheses, or what comes after that 1/3 minus 9?
Negative 1/4 p.
Yeah, which really, here it's being used as minus. So it's both, but we would say minus 1/4 p. And then, yeah, plus 1, because the opposite of a negative is a positive. You with me, dude? Every time I look back there, you're not right, so I'm just checking. We good? So, are we all fine with my color coding, by the way? Like, this is one expression. I just wanted you to see nothing happened, things did happen. So now I'm going to switch, because we're beyond that. I'm going to go in just straight green now.
Woo!
What should I do?
Good afternoon. Colin Williams, please come to the office. Colin Williams to the office, please. Thank you.
Since there's a 1/3 p and there's a 1/4, well, I guess that works. Maybe.
Do they both have the same variable?
Yes.
So are they like terms?
Yeah.
Yeah. So these like terms we should try to put next to each other. So I can say 1/3 p minus 1/4 p, but then I still have the minus 9 and the plus 1, so we have minus 9 and plus 1. 1/3 and 1/4. This sucks.
Because, wait.
Wait. So Josh, to add or subtract fractions, which is what we're trying to do, what do we need?
We need to make both denominators the same.
A common denominator. How can I get a common denominator here? What would
In this case,
be?
you can multiply them by each other, but
So what would be my
so
denominator?
your denominator would be 12.
Yeah, my common denominator is 12. Here, what do I multiply these values by? 4. So hey, give me your eyeballs for a second. Don't try to write this yet. Then here we would multiply by. So here's what happens when we do the common denominators. We're not changing anything. We're just changing what it looks like. This becomes 4/12 p minus 3/12 p minus 9 plus 1. Because the minus 9, what? Actually, can we combine minus 9 and plus 1?
Yeah.
Yeah, if I'm at negative 9 and I go up 1, where am I?
Negative 8.
Negative 8.
So it is negative 8. And 3/4.
Then, ooh, not 3/4. Be careful.
No, I'm saying the 4/12 minus, and then you get 1/12 p.
Yeah, we now get
Negative.
1/12 p minus 8.
It's like
Because if I have 4/12, I take away 3/12, all I have left over is 1/12.
it's like negative 7.11.
Dude, you can't combine these.
Oh, okay.
Stop trying to combine non-like terms. This is like a dog and a dinosaur. Or something like, I don't know how you can think about, like, you can't, they don't exist, like, they don't even exist together. You can't, like, dinosaurs are gone. We still have, well, okay, dinosaurs are gone is relative. Birds, whatever. But, like, I don't know a good analogy to talk about like terms, but it's like if you had a sandwich and a book. Like, I can't, this doesn't, like,
Sandwich book.
I don't, they don't combine. Non-like terms can't be combined. So, hold up. Are there any questions on this process? Here's where we're going to go back and look at the other method to solve this. So, go back up to that second kind of example part right here, the method 2. I want you, in your notes, to write subtraction is addition. Which you probably have elementary teachers that are like, you know, they obviously can't actually hear me, but they're like, oh my gosh, don't tell them that. subtraction is addition. Dot, dot, dot.
Oh, I remember.
That ellipse means there's more there
Plus a
of a negative. Subtraction is addition of a negative, because you can't get rid of that minus sign, but you can use it as a negative instead of a minus. So, now again, I need your eyeballs, and that's pretty much it. We have subtraction. We don't really like subtraction. It makes things difficult. So instead, we say, I'm going to make this plus a negative. But the problem here is, negative what? Well, when I look at this expression, how many of this expression do I have right now? How many 2 minus 7x's? 1, right? There's just 1 up here. So I can really say I'm going to add negative 1 of that expression. This seems complicated, though, because people are like, why are we doing this? Why would we not just use method 1? Here's why. Go to this third example down here. Now we have subtraction, but how many of this expression is there? 2. Because we have 2 times this expression. So the first thing we're going to do here, copy down what doesn't change. The negative 1.5h doesn't change. The plus 3 doesn't change. Now, I'm going to change some things. My subtraction, I'm going to make addition of a negative, but that's going to be negative what? Negative 2 here. So we make this addition of negative 2. Notice, guys, I still have this entire thing, the minus 2. It's just now being used as a negative 2.
So wait, we're not going to use that number to do distributive?
We are. Just hang on. So then I have my 0.5 plus the 4h. Questions here. How I was able to rewrite this.
How were you able to use the 2 twice?
We didn't. We changed how it was used.
Oh, okay. Never mind.
Here, they're saying take away 2 of this quantity.
Okay.
And I'm saying add the opposite of 2 of this quantity, which is the same, because adding an opposite is subtraction. Ellie.
Wait, so then what happened to the negative instead of the 0.5?
It's right here. So this symbol right
What
here
about the negative
is
sign?
this symbol right there.
What about the negative sign of the 0.5?
Oh, shoot. Yeah, that I did forget. So this is negative. Sorry, that was my typo. That was me writing incorrectly. So please check that your 0.5 up here is negative. My bad, I was moving quick. Caleb.
I saw 4h and the negative 1.5h.
Not yet. Because this, everything in here is being acted on by this. So the first thing I need to do, actually, I got to distribute. So I can't do commutative property until I get rid of these parentheses. I got to get rid of parentheses. So my negative 2 multiplies by my negative half. My negative 2 multiplies by my 4h. Please draw the arrows. My negative 1.5h plus 3 does not change yet. So I, again, just rewrite that. Now we can assume addition. We're always assuming addition. What is a negative times a negative? Sweet. What is 2 times a half?
1.
A whole. So we just get positive 1 for my first value. Then, again, you can assume addition. Negative 2 times 4h.
This is going to still be a negative.
Negative 8h. I heard a wait, why?
Oh yeah, so why did you say positive?
because I wanted to like clarify, we know it's positive. Like there's no question in our brain. Now,
You can put the negative 1.5
Yeah.
and plus they're both negative, so it'll come out as positive.
so negative 1.5h plus a negative 8h plus a 3 plus a 1. All I did was rearrange. You with me, Riley? When I combine these, a negative, if I'm at a negative and I go down further, I end up at a bigger negative. Sarah, are you with me? Because it doesn't look like it. This gets me negative 9.5h plus 4. And we, Josh, can I combine these values?
No,
Why?
because you said so, and that I'm gonna get in trouble if I do it again.
What aren't they?
They're not both. They don't like each other.
They don't like each other. They're not like terms.
One day I thought.
Any questions here? So we've got some time, but before we approach the end of class, I want to explain. Tonight, what I really want you guys to do is try that 7374 so that tomorrow we can start class with questions on the homework. Like I'll start class with the assignment up. Whatever you guys have questions on, we'll go over. But I need to know that you actually tried it before class and you're not just like, oh yeah, let's go over that one. So if and when you're working on it this evening and you have issues, message me, email me, text me, whatever. Let me know somehow. Don't call me, please, because that's kind of pointless. Like, you can call me if you want help, but we're going to go over this tomorrow in class. So, message me on Schoology, and actually, I think I've already got a post up saying, hey, what do you need help on with the homework? If I don't, I'll get one up here before extension starts, so that we know what problems need to be reviewed. I will not just take shout-out problems. You got to let me know before class. You can let me know like tomorrow morning or AO or whatever. That's fine too. You can write them down, but I can't just, like, I want to know that you tried it before class. Ella?
I'm pretty sure that I'm just curious. Will there be questions on the homework or we'll have to do the second process?
No, well, you never have to do the second process. And I love that you just asked that question. The alternative that I could do here. Please give me your eyeballs. You don't need to write anything. I'm just showing you another method. I could forget about all this and just at first look at 2 times this quantity. And if I do that, I would get a negative, sorry, that would be a negative 1 plus 8h. Then I can bring back the negative 1.5h plus 3, and now we just have subtraction between them, and then we can distribute the subtraction and do it just like method 1.
It's longer, but it seems easier.
So that's the thing. Whichever method you prefer, I don't care. I do care that you do well, but I don't care which method you choose. Exactly what Ella said. This type of way of doing it, distributing the 2 and then distributing the minus, will take more effort, but it might just be easier. You okay, Riley? Do you need to go to the bathroom or something? Is your eye hurting?
No, I'm good.
Okay. Sorry, some people, as the weather changes and things like allergies start to flare up, my wife's been having eye issues. I think I accidentally cleared that without it capturing. Ah! Well, whatever. Maybe we can get it to capture better. So, I want us, in the next example problem, to figure out which of these are equivalent, but I want to be efficient. Because, quite frankly, I don't feel like doing a whole lot of math. I'm joking. I always feel like doing math. But if we don't feel like doing math, let's analyze how we can decide which of these are the same and which of them aren't. So if we took method 1 and what we did was distribute the opposite, or the negative, or whatever you want to call it, which of these 4 options would this turn into? Give it a second for your classmates. If we did option 1 and distributed that opposite, which of these would it turn into? What do you think, Brady?
Would it be 2?
How do you know that?
Well, so positive 4 would turn into negative 4, and then negative 8 would turn into positive 8.
Is everyone with us on what Brady's saying? The opposite of 4 gives us negative 4. The opposite of negative 8 gives us positive 8. So option 2 right here is exactly the same as my beginning expression using method 1. It just does the opposite of those values. Leah. Ah! What is the difference? 6y, 6y. 15, 15. Negative 4, negative 4. So 1 is not the same because the minus 8y. 1 is not the same. So go ahead and cross 1 out, put a check mark next to 2. Now what about 3 and 4 over here? So now let's think about method 2. If I change my subtraction into addition of a negative, is this written correctly, or is 4, or are they both? So if I think about method 1, I would make this minus an addition of a negative 1. That kind of looks a little messy. So does option 3 turn my subtraction into addition of a negative?
No.
How does it not? I had subtraction, now I have addition.
But how do we get the 1?
Because how many of this is there? How many of this expression is there up here? 1 of them. That's where the 1 comes from. So this really, if we think about this problem, is saying 1 times 6y plus 15 minus 1 times 4 minus 8y. There's all... You don't. But when we switch it to addition of the negative, then we have to, because you can't just have a negative floating around there on nothing. It has to be a negative something. So since there's only 1 quantity of it, we now have a negative 1 quantity of it.
Well, how is there a negative 4 in this?
Ah, so let's check this out. So what I'm trying to get you to see is 3 is exactly the same based on method 2. I changed my subtraction into addition of a negative. That subtraction turns into addition of a negative. Now option 4, let's play this out and see if we can figure it out. Now, now that I've got my negative 1 by my up against my parentheses, Reagan, what would I do? Yeah, now we distribute. What would negative 1 times 4 give me? So yeah, it starts positive, gets multiplied by a negative, it becomes the negative 4. Then, what's negative 1 times negative 8? Positive 8. And what is minus a negative? Positive. So this right here is actually plus 8y. Option 4 is also exactly the same. The only option that doesn't work here is option 1. We will pick up right here tomorrow. Yeah. Oh,